All right, you guys, next let's try to get through questions 15 through 19 right quick. So identify the discontinuities of this function. Okay, so the first thing I want to show you guys is let's factor both the numerator and the denominator in this question, and it'll make it a lot easier. So the numerator ends up factoring down to, let's see, if I factor out a 2, it is 2 times, sorry, I did this on another piece of paper. If you need to review factoring, you can go back to previous videos or your book. 2 times x minus 3 and x plus 4. Okay, and if you multiply that out, you should get to, hopefully, no, I know, you will get the original equation back, and the denominator x minus 1 times x plus 4. Now, the reason I wanted to do it this way is because it makes it really obvious where your holes are. So really quickly, let's look at the vertical asymptotes here, right? Or where this function does not exist will be where the denominator equals 0, and that is where x equals positive 1 and x equals negative 4. Both of these numbers will make the denominator 0, in which case the equation does not exist. However, one of these is a hole and one of these is an actual vertical asymptote. Now you can see after you factor it out that we can cancel out the 2x plus 4's. Okay, that means if you can cancel it out of the original equations, that makes it a whole. Okay, so the x minus 4 is a whole. We can't cancel the x minus 1, so that makes the x equals positive 1 is a vertical asymptote, is x is positive 1. Okay, and the horizontal asymptote, since both the numerator and the denominator are the same degree, it would be 2 over 1. So the horizontal asymptote is y equals 2. Okay, if you put all of these things together, you should get C as your answer for 15. Okay, so 15 is C. Okay, let's clear this. What's next? 16. What is the factored form of the equation 4x squared minus 64? So the way they did this, of course, since it's a multiple choice equation, you can always multiply these out, and if you get an answer of 4x squared minus 64, that is the correct answer. If you want an easier way to do this, I think the way I did it was I said I can factor out 4 of everything, and that makes x squared minus 16. And then I know that became really easy to figure out. That was x minus 4 times x plus 4. So this is a factored form. However, there is not this factored form down here. The closest you get is 2 times x plus 4 times x minus 4, question E. But obviously that's not correct because it should be 4 and not 2. So then the next thing I looked at is 2x plus 8 times 2x minus 8. And I know that that one was the correct one. If I, instead of writing 4, if I wrote 2 times x minus 4 times another 2, this is all multiplication, times x plus 4, and then distributed these through, I get 2x minus 8 times 2x plus 8, which is D, which is the correct answer. Okay, and like I said, you can always double check this. An easier way, if you want to do it, it's easier for me to do it this way, but I think I did put this in the graphing calculator also to double check myself, and that was, nope, I guess I don't still have it, I'm sorry. I did have a graph from the question below, or right above this, that shows you the asymptotes. So don't forget, you can always graph this stuff. and double check, or do it the first time, double check algebraically. But as the book says, if you just check it a couple of different ways, you shouldn't get the wrong answer. You might not get the correct answer, but you shouldn't get an incorrect answer. All right, let's clear this out and move on to the next question. 17. Ooh. Cool. Okay, so which of the following statements is not necessarily true? Like I said, it's the same with operations using functions as it is with regular operations. If you think of 3 plus 4 is the same as 4 plus 3, right? You can think of 5 times 6 is the same as 6 times 5. Now, the what they did here, when they said f of g of x, they're just writing it a different way. F of g of x is the same thing. Remember, you can use this symbol, or you can just put it inside the other's function right here. The only one in this one that is going to not give you the same thing is the subtraction. Just like 3 minus 5 is not equal to 5 minus 3. So in this case, it is D. 17 is D. I was going to try to get to 19, so I'm going to keep going. 18 is the same. Oh yeah, I'll get to 19 because 18 is the same one we already did. So please, I hope you realize that it's the same and you can go back and check that one. And 19, just make sure you're drawing this out, and it should be fairly easy. We're looking for this angle with the question mark. Don't forget that that angle with the question mark is the same as this angle here. Okay, so the first thing we want to do is find this big triangle. We want to find the altitude here, and I want to find the altitude, which is the if I'm looking at my original angle, which is 57 degrees, altitude is the opposite, right? And I also have 70, which is the adjacent. So I have the opposite and the adjacent. So obviously the trig function that comes to mind is tangent, right? So the tangent, make sure your calculator is in degrees, please. I'm a poet. The tangent of 57 degrees is equal to the opposite, which let's just call it x, over my adjacent, which is 70. So x is going to be equal to the tangent of 57 degrees, which is just a number, put it in your calculator, times 70, and I got, I believe, 107.79, and what are we dealing with? Feet. Okay, 107.79 feet. Now I have on the other side, if I'm looking for this angle here, which is the same as the question mark angle, now I have 107 is the altitude right here. I still have the opposite and the adjacent. The difference is I do not have the angle. So let's clear this out, and I'm going to write up here really quick that x is, before I forget, 107.79. And I'm doing that from memory, you guys. So if your answer is just off by a decimal point, let's just assume we have the same thing. So what I mean to say is this altitude here is the 107.79. Now I'm going to be using this length, which is, no! It's like the third time this, I need to get this taken care of, you guys. I think I'm touching something on this mouse pad. Okay, so once again, my x is equal to 107.79, which is this number here. square minutes. Okay, and this is 100. And the reason I want to find this angle is because it is the same, if you remember from your geometry rules about parallel lines, as this angle, which has the actual question mark. So I'm still going to use tangent because I still have the opposite and I still have the adjacent. So I'm going to say the tangent, but the problem is I don't know the angle, so I'm going to use theta. The tangent of theta is equal to 107.79 over 100. Okay, so my tangent of theta is 1.0779, right? But that's just the tangent, that's not the actual angle. I have to put into the calculator, remember this, the arc tangent of theta, okay, in order to get my answer. So the arc tangent, except instead of putting theta there, I'm going to actually put in 1.0779. So in your calculator, you can type in second tan. So you're going to type in second tan, and then the number you're going to put in is 1.0779. Again, we've done all of this in degrees, so make sure that you are still using degrees in, I don't know why it does that, in your calculator. And if you do that, you should get that angle that you are looking for. That angle that you are looking for, theta, equal to, I'm going to do it really quick, in your calculator, 47.15 degrees. So that angle is 47.15 degrees. Don't ever forget what you're looking for. You're looking for an angle in this one. You're not looking for height, you're not looking for length, you're not looking for the tangent. You're looking for the actual measure of the angle. So you can kind of check your answer based on what you think that angle should be. Alright? And that was 19. Cool. I'll stop here, upload this, and then do the next 5 or so. Thank you.